Through this presentation, I am going to explain the pipeline performance that is in the module 5. First of all, I am going to explain the introduction. What are the introduction part? In the realm of digital design computer architecture, the pursuit of enhanced performance is a perpetual endeavor. At the heart of this pursuit lies the optimization of pipeline performance. A critical aspect directly impacts the efficiency and speed of computational tasks. Today, we delve into the significance of pipeline performance and explore strategies to maximize it within digital design computer architecture. First of all, what I am going to explain in this PPT, let's see the index part and the table of contents. That is definition of pipeline, then importance of pipeline performance, then formulas, advantage and disadvantages of pipelining. What is the importance of pipelining in daily life, and what is its disadvantage, what its effect. So let's discuss it, and then finally come to the conclusions. So what is the definition part of the pipelining? Pipelining, it is the process of arrangement of hardware elements of CPU such that its overall performance is increased. It is the arrangement of hardware element in which overall performance of the CPU should be increased. In pipelining, multiple instructions are overlapped in execution. What happened in pipelining? In pipelining, the multiple instructions are overlapped in during the execution time. So the potential increase in performance resulting from pipelining is proportional to the number of pipeline stages. So potential, what is the potential is directly proportional to the number of pipeline stages. So now, however, this increase would be achieved only if all pipeline stages require same time to complete and there is no interruption throughout program execution. Unfortunately, this is not true. So now let's come to the what is the importance of pipeline performance. There is four importance of pipeline performance is given. That is, first of all, enhanced throughput. Second one is the reduced latency. Then third one is the resource utilization, and fourth one is the scalability. So first, enhanced throughput. A well-optimized pipeline facilitates the concurrent execution of multiple instructions, thereby increasing the overall throughput of the system. Second one is reduced latency. By breaking down the execution of instructions into smaller sequential stages, pipelines help in pipelines help in reduce latency. So pipeline helps in minimizing the latency of individual operations. It will minimize the operations of the CPU, leading to the faster processing time. So the CPU work more faster. And third one is the resource utilization. What is it is the efficient pipeline designs enable a better utilization of hardware resources, maximizing the computational capabilities of the underlying architecture. So now the fourth of importance is of the scalability. As computational demands continue to escalate, pipelines offer scalability by enabling the parallel processing of in this CPU parallel processing of tasks will be working in pipeline performance, ensuring that the system can accommodate increasing workloads without compromising. So it's compromising performance of the CPU. So let's discuss the what's its formula and it's about the explanation of the clock cycle. First of all, I'm going to discuss the concept of pipelining and why should the pipeline should be used in our daily life. Pipelining concept should be used in every processor nowadays. In every processor that we see and we use, the pipelining concept should be used. So before I'm going to explain the concept of pipelining, discuss the need of pipelining and how CPU should work. So first, everyone want to make the performance of the CPU very high, so CPU should work faster. Everyone we want that the CPU work faster so that the we can work properly and more faster in comparison to other tasks, so we get more times for other works also. So So if you want to make the performance of so if we want to make the performance of the CPU area, then what we can do it, what are the methods that we can do to increase the pipeline perform to make the performance of the CPU should be high, so that it's work more better. That there is two methods mainly. That is, the first one is the circuit change, that installation cost a faster circuit, that install and install the faster circuit. First one is circuit change and install faster circuit. Second one is arrangement of hardware in such a way that the multiple instructions should be executed during at the same time. Second one, during the arrangement of hardware, we can arrange the hardware in such a way so that the multiple instructions should be executed at the same time. Multiple instructions should be executed. Circuit, but here there is two methods, circuit change and the arrangement of the hardware. So but circuit change is not a good method. Why? Because circuit change we can change the circuit and install the new one, that is more costlier, its cost should be increases. Because like, let's take the example of iPhone. We see that the iPhone 13, 14, 15, day to day in every year, say the process should be increased. 13, 14, 15 comes, but the price of 13 what less, 14 increases, then 15 comes, its price increases. So day to day its cost should be increases. So the better method to increase the performance of the CPU is the arrangement of hardware in such a way that the multiple instructions should execute in a at the same time. So let's see with example, then go to the clock cycle. First, let's take the example. There is what, let's take this is the shop. Let's say here I can order it, here payment is done, and here what happened, receive our order. So let's take C1 car comes, then it go to the order, then payment, then receive. So if let's take here, see, we can see the two cases. First off, if no pipelining, and if there is pipelining. If let's first see the what happened if there is pipelining. If there is pipelining, then C1 goes to the order, then what, payment, then receive. If C2 car comes, then what happened, order, when first car person payment done, then C2 car person order it, then when the C1 car person receive the product, then second person payment does, and then receive the product. So this is the method. But if there is no and so on, but if there is no pipelining, then what happened, first car comes, then order, payment, and then receive. But if there is no pipelining, then first person have to wait and takes more time. If first car person done all the things, then second car person start ordering it, payment done, and then receive the product. So it's take more time. Here first second car person have to wait only one times, but here there is wait to 3 second. Let's take 3 second, assume that, and here second car person have to wait only 1 second. So what happened in what is the importance of pipeline? In pipelining, we can see that there is less time is consumed, and the second and the in there, if there is no pipelining, then the more time is taken. Now I am going to explain the clock cycle part with the formula. Here there is segment number written, what, 1, 2, 3, 4, 5. There is 5 segment pipeline. T1, 2, 3, 4, 5 is the segment pipeline. T1, T2, T3, T4, T5, and T6. It is called the number of instructions or the task. So K segment pipeline is represented by K. What here? 1, 2, 3, 4, 5 is the segment pipeline, that is 5, and 1, 2, 3, 4, 5, 6. It is called the what? Say instruction, that is n equal to 6. So how we can calculate the phase duration? That is there. It is written in this 10 till 10. So how it is the phase duration? So how we can calculate it that the phase duration is till 10 10 second or 10 something in unit. So let's see the formula. Time duration formula is K plus n minus 1. What is K? There is 5 segment pipeline, then n, there is 6 minus 1, 6 5 11 minus 1, that is 10. So there is a 10 till 10 phase durations. So what is let's see that KTP, time required, total time. How we calculate the total time? Total time is equal to KTP. Total time equal to KTP plus n minus 1 into TP. So pipelining, how we can calculate what is the formula of pipeline efficiency? Pipeline efficiency should be calculated using the SK by K. What is K? SK, that is n, and what is K value? K plus n minus 1. So we concluded the, let's take the example how can we calculate that the pipelining. Let's take TP. Here we can see that TP equal to 20 nanosecond and K equal to TP equal to 20 nanosecond and K equal to 4, n equal to 100. Then how we calculate that? K plus n minus 1, that is 4 plus 99 into 20, that is the 2060 nanosecond. So here is the formula. TP is the clock cycle, TK is the time required to complete the n task, TK equal to K plus n minus 1 into TP. That's the formula. Let's come to the let's see what is the speed up formula. Speed up formula is Sk equal to n into Tn divided by K plus n minus 1 into Tp. So that is equal to Tn by Tp. What is Tn? Tn is the clock cycle and Tp is the what? Tp is the clock cycle to complete each sub operations. There is difference between Tn and Tp. What? Tn is the clock cycle. There is formula is given, Tn equal to K into Tp. Also that's same thing. And TP is the clock cycle time to complete each operation. Let's come to the what is the advantages of pipelining and its disadvantage, and then come to the conclusion. So what is the advantage of pipelining? Pipelining is widely used in modern processors. See, I can explain in earlier that in nowadays in every processors we can use the pipelining methods. Because why it's important, I explained it earlier. Second advantage is quicker time of execution, larger number of instructions. We can pass the larger number of instruction and then it's execute the system process in a quick time. So too much faster working processor is going on. Third one is the more efficient use of processor. We can use the efficient use. We can use the new processor that is highly efficient than earlier processors. What is the fourth one? That is the arrangement of the hardware so that more than one operation can be performed at the same time. So we can arrange the hardware so more than one operation can be performed at the same time. Fifth one is it is efficient for application that need to repeat the same task in many times with different set of data. It is the efficient applications. And what is the disadvantage of pipelining? Pipeline organization requires complex compilation techniques. This is the disadvantage. Because why? Because the complex compilation technique it required, so it's not easily available, and there is too much problem regarding this thing. And second one is pipelining involves adding hardware, then cost of the system increases. So I can explain two methods, but if I add the new hardware in the system, then cost of the system increases. I also explained that the let's take example of I explain the iPhone. So new processor comes and then the prices of the iPhone increases. So here also same, we can add the hardware in the system, then cost will be increases because new features added in this that's why price increases also. So finally come to the conclusion. What is conclusion? In conclusion, maximizing pipeline performance is paramount in digital design computer architecture, as it directly correlates with the efficiency, speed, and scalability of computational tasks. By understanding the key factors influencing pipeline performance and implementing optimization strategy effectively, we can unlock the full potential of digital design computer architecture, sharing in a new era of computational power and efficiency. So we can conclude that there is much more better method of pipeline performance. It's highly efficient to use the new processors and so that's it. Thank you.